Good morning and welcome to this FRONIUS webinar on the basics of networking. My name is David Porter. I'm one of the technical advisors here at FRONIUS in the UK, and today I'm joined by Mitchell Friedman, who's our IT coordinator, and also Natalie Woodford, who will be taking the questions during the course of today's training. So we brought this webinar online as we get a lot of questions from installers about the process of setting up data managers and connecting those to routers and understanding a bit more in detail about the whole IT infrastructure involved in setting up a data manager. So I'm very pleased that we have Mitchell here, who'll be able to give us a bit more insight into the sort of basics of the network working. And then I'll also talk through how we connect our data manager into a network and how we get those systems online. So first of all, we'll have a look at the different types of connections available and the sorts of routers we have, the sorts of equipment that we'll have in your own house or in a larger commercial or public sector situation. We'll then have a look at network theory and understanding what an IP address is, how we use those in setting up a data manager. We'll have a quick look as well at things such as cybersecurity and GDPR. And then we'll finally go through the data manager connection process and how to get that system online. So I'd like to pass over to Mitch now, and he'll start discussing.
Great, thanks, David. Okay, so good morning, everyone. And as we said, we're going to start by taking a look at some types of connections and routers. So we'll take a look at wired and domestic and business routers and what the difference between them is. And we'll take a look at the power line communications and the basics of what that is as well. And then we'll also move on to Wi-Fi and its effective range, the benefits of multiple routers and amplifiers. And as you can see there, we'll also look at Wi-Fi repeaters and Ethernet and so on. So first I will take a look at wired internet. So most companies of around 50 people or more have larger routers than you can see here in the left of this slide here compared to the home router. And often home routers only have one antenna to boost the signal. So one of the core differences between a home and a business router is that business class routers actually will be more expensive, obviously, and it's also designed to last a lot longer. Business routers tend to last around a decade, whereas home routers would normally be less than half of that. And consumer grade hardware is also designed to work with a few different devices, things like smart TVs, PCs, tablets, or a gaming system, and so on, all of which have periods of inactivity and varying demand on bandwidth. And you compare this with business grade hardware, which is being used at least 8 hours a day, 5 days a week by potentially dozens or more users. So it's designed to be stable under a consistent and heavy workload all day long. It is true, however, that home routers are becoming more powerful because we're using the internet more and more for things like entertainment, education, and even home appliances like lights and temperature while we're out of the house. So this means that the newest home routers can access the latest Wi-Fi frequencies that you normally see in business settings. So another difference that's beginning to shrink is the increase in security and protections for home routers with the ability to detect and stop more intrusive traffic like malware. So there are still some fundamental similarities. So the difference between home and business routers is a matter of degrees, really. And one way that you could think of it is like a Formula 1 car or other high-end performance cars. The technology that's created for them and employed by them gradually filters down throughout the different levels of quality, and so it becomes standardized throughout the industry. So we'll take a look at Ethernet. So Ethernet, as you may already know, is a family of networking technologies used commonly in local area networks or LAN, metropolitan area networks or MAN, and wide area networks or WAN. And it was first introduced in 1980 and it was standardized in 1983. So the most obvious difference between Wi-Fi and Ethernet is that one transmits data via wireless signals and the other transmits over cable. So this means that Wi-Fi provides greater mobility for users who need to connect to a network while moving freely around the space. And compare this with Ethernet, which is generally faster than a Wi-Fi connection and it provides greater reliability and security. And if you require a more stable and secure connection, then the cable is more appropriate. So there are a number of variables that determine actual speed of a Wi-Fi and Ethernet connection. The fastest Ethernet today tops out at around 10 gigabytes per second, whereas the fastest theoretical Wi-Fi speed maxes out at around 6.9 gigabytes per second, although the actual speeds tend to be much lower than this. So again, an Ethernet connection is much more secure than a Wi-Fi connection. and data on an Ethernet network can only be accessed by physically attaching a device to the network, while data on a Wi-Fi network can be more easily intercepted. So Wi-Fi is also more susceptible to interference from electrical signals or devices from physical objects that can block the signal. Therefore, Ethernet is more reliable and it's insulated from interference and unaffected by the presence of physical objects. So consequently, uploading large files, streaming video, or using other high bandwidth applications is best suited to Ethernet connections with lower latency and faster data transfer. However, of course, Wi-Fi is undoubtedly more convenient than Ethernet because you're able to move freely throughout the space and the signal's range. So we'll just take a quick look at the types of Ethernet connections. So network cables are known as RJ45, RJ literally just meaning registered jack. And the most common types you can see here is the Cat5 all the way up to Cat7. So the Cat5 are the older ones, and these are most commonly found in networks and telephony, but they are starting to be outdated now as the transfer rate is quite low, only up to around 100 megabytes. Compare that all the way now with the newest Cat7Es, which move all the way up to 1,000 megahertz frequencies and can have up to 10 gigabyte transfer speeds. Okay, so we'll take a look at what the actual cables themselves look like. So you can see here, the Cat6 only has the overall jacket, which is the blue part around the actual cable itself, and then the twisted wire pairs, and it has no real protection. Then you move to the Cat6A, and actually you can see there has the braided shield around each set of wires, just to provide some stability and connection there. And then you move to the Cat7, the newest wires, and that has the overall jacket around it, and then inside that has the braided shield, and then around each pair of the twisted wires also has a foil shield as well. So this protects the signal and protects the actual wire itself and increases your transfer rates. So now we'll move on to Wi-Fi. So as I'm sure you will be aware as well, Wi-Fi is a family of wireless network protocols which are commonly used for local area networking of devices and internet access. So Wi-Fi is actually a trademark of the non-profit Wi-Fi Alliance, and they actually restrict the use of the term Wi-Fi certified to products that successfully complete interoperability certification testing. So Wi-Fi is designed to interwork seamlessly with its wide sibling Ethernet, as we've discussed, so compatible devices can network through wireless access points to each other, as well as to wired devices and the internet. Wi-Fi's wavebands have relatively high absorption and work best for line of sight use. So many common obstructions such as walls, pillars, home appliances, etc. can greatly reduce the range, but this in turn also helps to minimize interference between different networks in crowded environments. So an access point or hotspot often has a range of around 20 meters indoors, while some modern access points claim a range of up to 150 meters outdoors. So Wi-Fi is potentially more vulnerable to attack than wired networks because anyone within range of a network with a wireless network interface controller can attempt access. So to connect to a Wi-Fi network, a user typically needs the network name or SSID and a password. And the password is used to encrypt Wi-Fi packets to block eavesdroppers. Wi-Fi protected access, or WPA, is intended to protect information moving across Wi-Fi networks and includes versions for personal and enterprise networks. Developing security features of WPA have included strong protections and new security practices. So a wireless access point, or WAP, or more generally just AP, is a networking hardware device that allows other Wi-Fi devices to connect to a wired network. The AP usually connects to a router as a standalone device, but it can be an integral component of the router itself. An AP is different from a hotspot, which is a physical location where Wi-Fi is actually accessible. So an AP connects directly to a local area network, usually Ethernet, and then the AP then provides wireless connections using wireless LAN technology, typically Wi-Fi for other devices that use wired connection. And next up here, we have the Wi-Fi repeater. So a Wi-Fi repeater is used to extend the signal or coverage area of your Wi-Fi network, and it works by receiving the existing signal, amplifying it, and then transmitting the boosted signal. And with a Wi-Fi booster or repeater, you can essentially double the area that your Wi-Fi reaches. However, while range extenders are good for home Wi-Fi networks, they're not efficient or for businesses because they can only support a limited number of devices at one time, usually no more than 20. And also, while range extenders do increase the coverage of a Wi-Fi router, they do not actually increase its available bandwidth. So depending on the number of available devices that you have connected simultaneously, a range extender could actually end up weighing down your connection. So access points, on the other hand, can host up to 60 devices simultaneously at the same time. Therefore, by installing access points throughout a large office or building, users can roam freely from room to room without experiencing network interruptions. And as they move through the building, the device will shift from one access point to the next without interruption. So now we'll take a look at some power line communications and the basics of that. So it's also known as PLC, or power line carrier, power line digital subscriber line, mains communication, or power line telecommunications, or even power line networking. And it's used to carry data on a conductor that is also used simultaneously for AC electric power transmission or electric power distribution to customers. So you can see here in the diagram that the telecommunications network sends the signal to a base station and then onto the transformer unit where it meets the power transmission line. The two then meet and travel along the same cabling and eventually reach the destination, and the two electrical signals are split again to give both power and internet. So a wide range of PLC technologies are actually needed for different applications, ranging anywhere from home automation to internet access, which is often called broadband over power lines, or BPL. And most PLC technologies limit themselves to one type of wires, but some can cross between two different levels. So for example, the distribution network and the premises wiring. So various data rates and frequencies are used in different situations depending on the need. PLC systems operate by adding a modulated carrier signal to the wiring system. Different types of PLCs use different frequency bands. Since the power distribution system was originally intended for transmission of AC power at typically around 50 to 60 Hz frequencies, power wire circuits have only a limited ability to carry higher frequencies. And this is known as the propagation problem, and it's a limiting factor for each type of power line communications. And PLCs are actually split into several different types, so we'll just name those for you. You have the long haul low frequency, which ranges from around 24 to 500 kilohertz, the medium frequency, which is around 100 kilohertz, the high frequency, which is greater than 1 megahertz and is used by home networking or LAN, and the BPL, and then finally the ultra high frequency, which is greater than 100 megahertz. Some benefits of this technology is its low cost implementation. There's no need for extra cables, and almost all regions are covered by electrical networks, even remote locations. And the two main uses are for data transmission in low bit rate but long range for low frequencies, and broadband transmission but reduced range for higher frequencies. Okay.
So the FRONIUS Data Manager is designed to offer maximum flexibility when it comes to connection options. The device itself is equipped with Wi-Fi access and also with LAN. So that means you can connect your laptop or smart device either by Wi-Fi or by a hardwired cable, and then you can connect the device to the router also by Wi-Fi or by a LAN Ethernet cable. You've also got that option of using power line communications. So if you have a site where you don't have a very strong Wi-Fi signal, and it's going to be really difficult to run a LAN dedicated cable through the building, you can incorporate a power line module at either end, one near the data manager and one at the router, and then connect using patch leads into each of those devices.
So we're going to take a look at nets and networking theory now. We'll take a look at the IP address ranges, what they mean and what they're used for. We'll take a quick look at DNS, static and dynamic ranges, proxy servers, FTP, and APIs. So an IP address or internet protocol is a numerical label assigned to each device connected to a computer network that uses internet protocol for communication. So it serves two main functions: the host or network interface identification and location addressing, and they're always unique. So IPv4 defines an IP address as a 32-bit number. However, because of the growth of the internet and the depletion of available IPv4 addresses, a newer version called IPv6 using 128-bit addresses was standardized in 1998. So network administrators assign an IP address to each device connected to a network, and such assignments may be on a static or dynamic basis, which we'll go into further later on, depending on the network practices and software features. So an IP address serves two main functions. It identifies the host, or more specifically its network interface, and provides the location of the host in the network, and thus the capability of establishing a path to that host. The header of each IP packet contains the IP address of the sending host and that of the destination host. So it always is a set of 4 numbers, each ranging from 0 to 255. So the full range goes from 0000 to 255, 255, 255, 255. And probably the most well-known one of those is Google's, which would be 8.8.8.8.8. And the reason for this is that each of the numbers is actually an 8-digit binary number or octet, hence 32-bit number. So as you can see in the example here, 192 becomes 2 ones, 6 zeros, and so on, with each number being converted into its binary format. All computers work on a binary or hexadecimal format, but it is much easier for people to work in the decimal format. Each binary number is shown as a whole number, and the IP address is split into two separate parts. You have the network ID on the left side and the host ID on the right. The network ID is part of the IP address starting from the left that identifies the specific network on which the device is located. So as you can see in our example here, for a typical home network, the first three sets of numbers are the network ID, so 192.168.1. And then the host ID on the right is the part of the IP address which is not taken up by the network ID, and it identifies a specific device called hosts on that network. So continuing with our example, the IP address shown here, the host ID would be 34, which is the device's unique ID on this network. So on your home network, for example, you would see several devices with 192.168.1, and then maybe 1, 2, all the way up to 30, 34, etc., depending on how many devices you have in your home or your business. And each is an individual device, as we've already said, and you can think of it as street addresses within a city. So the street name is the network ID, the house number is the host ID. So no two streets will be the same, and on a particular street, each house number is unique.
So it's important to know that there are two types of IP ranges. There's the public IP addresses, which are for communications between your router and the internet. And then there are also private IP ranges. And these are only allowed in a local area network. So a device with a private IP cannot communicate with that IP over the internet. The FRONIUS Data Manager, when connected, uses a IP address of 192.168.250.181 for its Wi-Fi access point. So that's for local communications between your laptop and the data manager. With a typical domestic router, you'll be in the IP range of 192.168.0.xxx, where xxx is your individual host ID for your individual device. Each network will also have a subnet mask, and that subnet mask denotes which part of the IP address is the network ID and which part is the host. So for example, you can see 255.255.255.0 means that the first three octets relate to the network ID, and the last one relates to the host ID. And this is the most common setup that you'll see when you're configuring a data manager. So if we look at the typical IP addresses found on a data manager system, you'll see we have the local access points, the LAN local access point between the laptop and the data manager will have an access point IP of 169.254.0.180, whereas the Wi-Fi access point has an IP address of 192.168.250.181. So these are the IP addresses we would type into our browser when we want to communicate directly with the data manager. When you connect to your router, the IP address will be dictated normally by the router itself. And then, for example, you'll be at 192.168.0.53. We then have on the right-hand side the public IP address for that router. And this could be one of many IP addresses, but we're saying this example, for example, 80.47.201.13.
Okay, great. So now let's take a look at some more networking theory, and we'll go into a little bit onto static and dynamic ranges. So dynamic literally meaning that this type of IP address can change or be changed, and static meaning that these stay the same. So most IP addresses assigned today by ISPs are dynamic IPs because it's more effective, cost effective for them and for you in terms of home networks. And most of the time, it will not be down to you to decide as a consumer, although businesses tend to use static IPs for various reasons. So generally, a static IP address is assigned by request for a fee by an IT administrator at work or for yourself at home, and technically a dynamic address can change at any time. However, it's not actually likely. It may not really change for months, and even if it does, you would be unlikely to notice. So advantages of static IP addresses. Businesses are better suited for it than residences. It's better for dedicated services such as mail, FTP, which we'll talk about in an upcoming slide, and web servers. It's good for creating or hosting computer servers. It makes it easier for geolocation services to accurately assess where you are. Some of the disadvantages of dynamic IP addresses, it is possible that upload and download speed will be slower than on static, but for average everyday use, this will not really be noticeable. And you wouldn't be able to set up a reliable server with a changeable IP address, which again is not relevant for most individual consumers, but useful for businesses. So static IP addresses are requested by people or businesses who want more control over their connection along with more capabilities. So if all websites use IP addresses, why would you need to use words to find a website rather than typing in an actual numbered IP address every time? So that's actually due to the DNS, which is called Domain Name Services or Domain Naming System. And you can think of it as an address book, and it maps domain names to IP addresses. And because we as humans have a much easier time remembering a name than a string of numbers, DNS is very useful for the operability and usability of the internet, the average person. So in essence, DNS is simply a database that links meaningful names, which is the host names, such as HTTP www.microsoft.com, to a specific IP address, such as 192.168.124.1. So simply linking addresses to names is just the beginning though, however, because DNS has many more features in addition to host name to address mapping. So the key features of host name to IP mapping are as follows. The mapping of addresses to names and vice versa, known as records, are stored in a database. The DNS database is distributed, and the DNS database also stores additional records. So now we'll take a look at proxy servers. So a proxy server acts as a gateway between a user and the internet, and it's an intermediary server separating end users from the websites they browse. So if you're using a proxy server, internet traffic flows through the proxy server on its way to the address you requested. The request then comes back through that same proxy server, and the server forwards the data received from the website to you. Organizations set up proxy servers to control and monitor how their employees use the internet. And organizations can also get a better overall network performance with a good proxy server, as it can cache or save a local copy of popular websites. So this means that if hundreds of people will also attempt to access the website at the same time from the same proxy server, then it would only actually send one request to that website, which saves massively on bandwidth and improves network performance. Okay. Organizations also use proxy servers to browse the internet more privately. Some will change the IP and other identifying information, so the destination server will not know who actually made the request, which keeps your personal information and browsing habits more private. They also provide security benefits on top of the privacy benefits. So you can configure the proxy to encrypt web requests, for example, to prevent anyone from seeing your transactions. It also prevents malware sites from any access, and they're especially effective when used with a VPN. So this is something that I think most of us will be more familiar with now due to the home working this year. So the VPN is a direct connection to the company's network by rerouting the end user's IP address to another. And so by using it, the company can verify that their users have access to the resources that they need, while also providing a secure connection for the user to protect company data. Okay, so now we're going to move on to a little bit of cybersecurity and information protection. So cybersecurity is a combination of defined processes and procedures, the use of security software and protocols, and careful and attentive employees. And so this last part is really the most important part, because the most secure data in the world is not safe at all in the hands of a reckless employee. So we'll also take a look at ports and what they are, some information regarding passwords and GDPR, and what are the basic rules and regulations of that. So you can see here, a port is a communication endpoint identified by a 16-bit number, which is known as the port number. And the most common protocols that use port numbers are TCP, or Transmission Control Protocol, and UDP, User Datagram Protocol. So these images are examples of the types of computer ports that you would have seen. You may have seen these in your home as well as around the workplace, where the router is plugged in or just on your computer itself. And these are networking ports that you have here, the RJ45 port for internet. There's also USB ports there, which are for data transference. And then you also have things such as display ports. So you have things like the VGA, DVI, and then more recently HDMI and display port. So you can see here some of the most common port numbers. A port number is also always associated with an IP address of a host and then the protocol type of communication. So a common example for the use of ports is the internet mail system. A server is used for sending and receiving email, generally needs to be services. So the first is used to transport email to and from other servers. This is done by a simple mail transfer protocol, or SMTP, which usually listens on TC port 25 for incoming requests. The second is either Post Office Protocol, or POP3, or Internet Message Access Protocol, which is IMAP, which is used for the email client applications on users' personal computers to fetch emails from the server. POP listens on TC port number 110, as you can see here. Both services may be running on the same host computer, in which case the port number distinguishes the service that was requested by a remote computer, be it a user's computer or another mail server.
So one of the useful features of the FRONIUS Data Manager is that we can obviously collect the data, send it to the internet and view it on our SOLAR.WEB platform. In order to do this, we need to make sure that certain ports are opened to allow data to be transferred from the data manager to the internet. Those ports are 49049 UDP, 15015 TCP, and 80 TCP. So on most domestic routers and unmanaged networks, these ports will already be open as a default. However, if you have a managed network, so for example, a school or a larger business or public sector organization, you will need to get permission to open these ports from the network administrator. Normally, once they've been opened, they'll be opened for a specific IP address. So it's important to set a static IP address in the data manager. And we'll see how to do this a little bit later. Quite often, most installers will actually find it easier just to install their own dedicated 3G router, which is purely installed for the solar system. And that means that you don't have any issues around getting access to the network on site, and you don't have any security and access problems in future. Another very useful feature is port forwarding. And this enables you to remotely configure and change settings on the FRONIUS Data Manager, for example, load management, export control, and also to undertake upgrades. To do this, you need to enable to open two ports, which are 22 and 80. This is done through the router's administration interface. So this will vary from device to device, but typically it will be found in the administration settings of the router. And also, FRONIUS has a number of passwords as default. So to connect the data manager to your laptop or to your phone through Wi-Fi, you'll need to use the password 12345678. We then have a default administration password for setting basic settings such as network connections and system names, and that is admin123. And then we have a technician password for the more advanced settings such as export limitation, and that password is service123. Now, if the system is secure and is not at risk of interference from any third parties, you can leave these default passwords in place. However, if you're going to have this system on a public network, or there's any risk of anyone making changes to the system, you can obviously change and put a more sophisticated password in place.
Okay, so we'll take a look at a little bit of FTP, or file transfer protocol. So this is a standard network protocol used for the transfer of computer files between a client and server on a computer network. Transferring files from the client computer to the server is called uploading, and vice versa, transferring from the server to the client is downloading. And to access an FTP server, users have to be able to connect to the internet or an intranet with an FTP client program. And the same with IP addresses. A protocol is a set of rules that network computers use to talk to one another. So FTP is the basic method for sharing files over the internet, and with the first version dating back to the early 1970s, and even the current FTP standard, which is RFC 959, is from 1985. Most companies, however, still maintain FTP sites where you can download software, device drivers, documentation, and reports. And connecting to an FTP server is very similar to connecting to just about any other server on the web. When you log into a secure shopping cart system, wherever it may be, you have to provide a server address, a username, and a password before you can exchange information with the server. However, it is also possible to connect anonymously if the server is configured to allow it. So for secure transmission that protects the username and password and encryption content, FTP is often secured with SSL or TLS, which is secure socket layer, which is part of the firewall, or the transport layer security. But we won't go into more details on those now. We'll take a look at the data manager.
So the data manager has a useful function called push services, which enables FTP push to a third-party server. This means that you can incorporate your PV system's data into another monitoring system or into external websites. Now, this is particularly useful for operations and maintenance companies who may be providing maintenance for a number of different installations with different inverter manufacturers. And it means you can see all the data in one place for all those different manufacturers. The FTP server administration or monitoring company will need to provide you with the server address and also the specific data that should be sent from the inverter. This can then be input into the data manager settings so that the data is pushed to the right server and providing the data that is required by the monitoring provider.
Okay, so we mentioned previously the APIs, and we'll take a bit more of a look at that now. So API stands for Application Programming Interface, and it consists of three parts. You have the user, which is you, the person making the request, the client, which is the computer that sends the request to the server, and the computer that responds to the request. And the most important part of the API is the interface. Essentially, an API talks to a program for you. So you can see here in our diagram, it can be for things such as games, television, any wearable devices or sensors, mobile devices, cars, and their smart systems and web applications. So someone will build the server first, since it acquires and holds the data, and once that server is running, programmers publish documentation, including the endpoints where the specific data can be found. This documentation tells outside programmers the structure of the data on the server, and then an outside user can query or search the data on the server, or build a program that runs searches on the database and transforms that information into a different usable format. So some examples of APIs that are commonly used would be things like weather snippets. So if you were to search weather plus your city on Google or even on your phone, often they have them now, you'll see a dedicated box at the top of the search results with current weather conditions and forecast. And this information isn't directly Google's or whichever browser you're using. They get it from a third party, which sends them the latest weather details in a way that they can easily format it. There's also the login using feature. So that would be another example where websites have a feature to log in using another site, such as Twitter or Facebook or LinkedIn and so on. And it doesn't actually log into those social media sites. Instead, it uses it to authenticate the user. And then a final example could be the Pay with PayPal option. So when you click on the Pay with PayPal button, the application sends an order request to the PayPal API, specifying the amount owed and other important details, and then a pop-up authenticates the user and confirms their purchase. So finally, if everything goes according to plan, the API sends confirmation of payment back to the application. And the APIs can be entirely custom, specific to a component, or designed based on an industry standard to ensure interoperability between devices and systems.
FRONIUS offers an API which is designed to enable developers to incorporate SOLAR.WEB data into other online tools. This is particularly useful for customers who may have many sites. They want to get access to that data, but they don't want to have to go to site to make changes and to redirect the data. The great thing is, as this is done through SOLAR.WEB, it can all be done remotely. This means that we can incorporate the data into things such as smart home applications, so EV chargers that can collect the solar data and modulate the power supplied to cars, and also to feed in data into building management systems and smart home servers. what I would say is that this is quite a complex tool, and you do need to have experience with software development in order to implement this successfully.
Okay, so next up, I'll take a look at GDPR with you. So this is the General Data Protection Regulation, and it's a list of rules for the handling of consumer data, which came into force in May of 2018. The goal of the legislation was to help align existing data protection protocols while increasing the levels of protection for individuals. And the reforms were designed to help customers gain a greater level of control over their data, while also offering more transparency throughout the data collection and use process. Failure to comply with GDPR can result in large fines, so it can range anywhere from 20 million euros or 4% of your organization's annual revenue, whichever is greater. And these higher levels will be reserved for cases in which data infringement occurs, procedure for handling data aren't in place, and unauthorized transfer of data occurs, or web requests are ignored for customer data access. And then it can also move down to the smaller offences, where the fines will be halved up to around 10 million euros or 2% of annual revenue, again, whichever is higher. These are still for misuse of data, but on a smaller scale. So, for example, failing to report a data breach, failing to notify your customers about the breach, or failing to administer the correct data protection protocols. So, how to be GDPR compliant? First point is to obtain consent. Your terms and conditions have to be clear, and consent must be easily given and freely withdrawn at any time. There's the timely breach notification. So if a security breach occurs, you have 3 days to report the data breach to both your customers and any data controllers. And if your company is large enough to require a GDPR data controller, then that's what you need to do. And failure to report these breaches within the time frame will lead to fines. And then third, you have the right to data access. So if your users request their existing data profile, you must be able to serve them with a fully detailed and free electronic copy of the data you've collected about them. And this report must also include various ways that you're using their information. Next up, there's the right to be forgotten. And this is also known as the right to data deletion. So once the original purpose or use for the customer data has been realized, your customers have the right to request that you totally erase their personal data. Then you have the data portability, and this gives users rights to their own data again. So they must be able to obtain their data from you and reuse that same data in different environments outside of your company. And then penultimately, there's the privacy by design. And this section requires companies to design their systems with the proper security protocols in place from the start. And failure to design your systems or data collection the right way will result in a fine again. And then finally, we have the potential data protection officers, which was mentioned previously. So in some cases, your company may need to appoint a data protection officer, and whether or not you need an officer depends on the size of your company and at what level you process and collect data about your consumers. So does GDPR affect you? You can see here, is your company based, EU-based? If yes, then GDPR affects you. If no, do you have customers or clients in the EU? Again, if yes, then it affects you. If no, then you're safe.
So at FRONIUS, we take data protection very seriously. You'll see that when you sign up for our services, you'll have the option to opt in or out of newsletters and promotions, and also to make sure that you read and accept the terms and conditions for any FRONIUS digital services that you use. Okay, so having had a look at some of that networking theory, thanks very much, Mitch. What we'll have a look at now is the actual data connection options on the data manager. So in the most basic instance, there's 3 components that we have in our network. We'll have our data manager, we'll have our laptop or phone for connecting and commissioning the data manager, and then we have the router, which is going to be collecting and sending the data to the internet. We've got a number of different options for connecting to the internet. So first of all, we should assess the individual site, have a look at the best option. It may be that you have a long distance, difficult route for putting cables in, so you choose instead to work with Wi-Fi. If you're going to do this, I would strongly recommend using a wired connection to your laptop. And this just means that you're going to avoid having to switch Wi-Fi networks during the connection process, and you won't have any confusion between having your laptop on the correct Wi-Fi connection. You might, however, find it's much easier, more reliable to install a hardwired connection between the router and the data manager. In this case, I'd recommend using the Wi-Fi to connect between the laptop and the data manager. Again, for the same reason, you're not then going to be sharing the one LAN port for the two different connection options. You keep one method of communication for the router and then the other for the data manager. So the first step would be to set up the local access point between the two devices, the data manager and the laptop. And if you do that with Wi-Fi, you'll be using an IP address which is 192.168.250.181. And if you use the LAN connection, we'll be using 169.254.0.180. Once we've done that, we'll then establish the connection between the data manager and the router. So this will be done obviously by selecting the options within the data manager embedded browser interface. And then the final thing we'll do is connect the laptop to the router so that we can talk to the router, to the internet, and to the data manager, all through the same connection. However, sometimes you may actually not be able to make a connection to the router. For example, if you're working in a school or a hospital where it's managed network and there's no connection, or you just don't have a physical route to the router from where you're sat. So you can continue with the access point if there is no connection to the router available for your laptop. So that's basically the process. Now let's have a look how we do that within the data manager controls. The first thing we need to do is to switch on the Wi-Fi access point. So you can do this one of two ways. You can go through the display menus. You can go to Setup, choose Wi-Fi access point, and then activate the Wi-Fi access point. You'll then see the SSID for the device, which will start with FRONIUS 240. And you'll also see the green LED flashing here. This means that the Wi-Fi access point is open. The other option is to take the cover off the bottom of the inverter and move the dip switch in front of the LEDs from the B position to the A position. This has exactly the same effect, switching on the access point and making the green LED flash. So once you've opened up the access point, you can now connect either your LAN cable directly to the data manager, or you can go through the Wi-Fi access point and choose from your Wi-Fi connections the FRONIUS 240 SSID, and then enter the password, which will be 12345678. You'll see the device now says that it's secured with no internet connection. And we have what we see in the screen here, a connection locally between the laptop and the data manager. So we can now open up a browser, Chrome, Safari, whatever you choose, and go to the address bar and enter the IP address. As we said, this is 192.168.250.181 for a Wi-Fi connection. Hit enter and you'll come to the welcome screen for the FRONIUS Setup Wizard. Now we're only going to be looking at setting up SOLAR.WEB today. So what we'll do is we'll click on the SOLAR.WEB Wizard option. And you can enter now the various details for your system. So system name, the tariff, which is the feed-in tariff, if you're lucky enough to have one of those, or the grid supply tariff. That's effectively the cost of electricity per unit from the grid. Make sure to set time automatically, so this will automatically update the time for your system from the internet, and make sure you have the correct time zone listed. Now click forward. The inverter will now be scanned. The ID will be detected within the data manager, and you'll see the connected inverters listed here. Make sure to put the right power into the right-hand column. This is normally the power of the inverter, and make sure to do that in watts, not kilowatts, otherwise the graphs will be skewed. You can now click forward again, and we come to the network setup page. So depending on how you want to connect your device to the internet, you have various options. The first option is just to continue with the local access point with no internet connection. The second option is to connect via WLAN, in other words, wireless Wi-Fi. And the third option is to connect via LAN, so using the hardwired connection. If you choose the Wi-Fi, you'll have a list of available networks on the right-hand side. Click the network you want and select Set. You'll now be asked to enter the password for the Wi-Fi. This will be normally printed on the back of the router. So enter that into here, click the Save button, and you'll be able to continue. If you want to connect with the LAN connection, so the hardwired connection, normally as soon as you plug the cable in, it will connect to the network and you'll see an internet connection. However, if you have a static IP required, you can enter that into the settings on the right-hand side by choosing static and then entering in the designated IP address for your data manager. You can now click connect. The device will now connect to the router and you should see an internet connection available. In the middle of the screen here, you'll see that you have a new local area network connection set, and you'll be given a new IP address for the data manager. So the data manager is now connected to the router, and the router has assigned an IP address to the data manager. What we want to do now is to disconnect the laptop from the data manager and instead connect to the router. So we take the Wi-Fi connections, we now connect to the same router, so this FRONIUS guest router, click connect, and we should now see the laptop connecting to the router. We click on the new IP address for the data manager. We now can continue the commissioning process, but instead of talking through the access point, we're now talking through the router. So we can now communicate between the laptop, the router, the data manager, and the internet. Let's click forward. You may get a notification to move the IP switch back into the B position, which is just for switching the access point off. Do that, and you'll be able to proceed to the next page. You'll now be asked for your administrator password. So the default password is admin123, and you can of course change this if you want in this page. You'll be asked to confirm by repeating the password. That should be identical, and you can click forward. So that's actually set the settings on the data manager. The next thing to do is to build a new system in SOLAR.WEB. So you'll be asked for your login details for SOLAR.WEB. If you've installed systems before, then great, you'll be able to click the login button. If this is your first time using the device, you'll need to register for a new account. So you enter your login details, so your username and your password, and log in. And you have three options. The first is to add a new PV system, which is more likely than not what you'll want to be doing. The second option is to add another data source to an existing PV system. So this might be some additional inverters you're installing on a new plant. And then the third option is to exchange a data source. So if you have a faulty data manager, you can replace the existing one on an existing system with a new one. But what we're going to do is to add a new PV system. You'll see a lot of the settings have been taken from your data manager commissioning, so the system name, and also you'll see your settings from your account being taken and put into the address contact details. Click submit, and you'll now see your system online within SOLAR.WEB. So you'll be able to see the live data shown in the bubble diagram on the left-hand side. And once the system's sent archived data back to the internet, you'll start to see a graph develop here. Please be aware that when you first install a new PV system, this will appear blank. Data will flow through over the course of the first hour, so it may take a little bit of time before that updates. So we'd also like to mention that obviously there's a lot of information that we've covered here, and we will be running a number of additional webinars in the new year to cover some of the more advanced features of the data manager, and also look at the commissioning process of the new Gen 24 inverters. So please keep in contact, and we'll certainly update you with the dates of the next webinars taking place. Well, thank you very much for your time. We will now have a quick look to see if there are any questions.